All right, so let's start a new file from scratch. Let's save this as, what happened to my notes here? Save this as 10.1 OpenGL. Intro. And save it wherever you save things. I'm going to put mine in my projects folder. Okay. All right, so let's talk really quick about OpenGL. How many of you have ever heard of OpenGL before this class? Yeah? And what did you usually associate OpenGL with? Like what was the context of where you had heard of it before? Yeah, video rendering. Most of the time people say games. It was really developed as a way to talk to graphics cards for rendering live games. But we were leveraging those tools to do live video rendering because games are live, and so is what we're doing in Max. It's all live. The reason why you use OpenGL is because it's how you can talk to your graphics card and actually do operations on the GPU, or the graphics processing unit, as opposed to running things on your CPU. So far, everything we've been doing in class is matrix-based video, which all runs on the CPU. And CPUs are really fast, but they're not quite fast enough for doing video, for rendering video, and it bogs down when you're doing particularly high definition videos and doing multiple operations on those videos at once. Let's see. So why is there a difference in what's the difference between CPUs and GPUs? Well, it's really how the chips are designed. CPUs are designed to do a whole bunch of different types of calculations, all one at a time, as fast as possible, and it has to do, say, it has to do some math operation and then take the result of that, store it in RAM, then do a different math operation, then grab that result that it just did and feed that into the next operation. So it has a lot of memory for storing these values, and it has a large instruction set of different math operations that it can do, a CPU. And that's optimized for doing the math calculations that it takes to run applications, to calculate whatever you're trying to calculate in your programs. GPU is a little different. In GPU, everything is optimized for doing simpler calculations on a smaller set of numbers, but doing multiple calculations at once. It has to do with like cores. A CPU, most of the time you have like one core, maybe you have two cores or a 4-core, or if you have a really big like Mac Pro, you might have an 8-core CPU. A GPU, and each one of those cores has a large amount of memory, of level 1 memory, for storing and recalling values. On a GPU, you have hundreds of cores, and with all just a tiny bit of memory per core. They're not really good at recalling values. What they're good at doing is doing lots of similar operations on the same numbers. Because when you're dealing with video, if you think about a pixel, if you have a 1080p video, it's 1920 pixels wide by 1080 pixels deep. And if you're looking at, say, a picture of a flower or something, if you're looking at all the pixels in just this upper right corner, there may be 200 pixels there and they're all green because they're all the leaf or whatever. And then some are slightly less green, but ultimately they're mostly all the same color. So the values are all similar. There might be slight differences, but there are similar values that are all grouped together. And what you're doing to those, you're doing the same thing to a large chunk of pixels. Like if you're calculating, or if you're taking a video file and moving it over to the right, all of those pixels, you're doing the same kind of transform operation where you're saying, okay, take this value and move it over whatever, 0.3, whatever your values are. And you're doing that same calculation to every single pixel. And so they've optimized those simple processes on large numbers of similar data on a GPU. And a CPU is more optimized for doing completely different calculations rapidly, one at a time. So that's the main difference. You can certainly use, and we have been, a CPU to render graphics. It just takes a little bit longer. Some of the graphics cards say that their GPUs will render graphics 200 times faster than a CPU. And last year I remember reading an article where Intel was arguing with that, saying no, it's that they're way inflating their speeds. We can render graphics pretty fast. It's not 200 times. It's only like 15 times faster. But still, that's 15 times faster than you can do it on your CPU. So it definitely makes sense to use the GPU when you can. It also, when you're offloading all of these little operations onto your GPU, it leaves your CPU open for doing other math operations. So if I'm rendering a bunch of graphics plus I'm doing math calculations, I have to fit those math calculations in the middle of all that rendering, and so it slows everything down. Now we can run two things at once because the graphics card's handling the graphics and the CPU is handling the math. And they can run at the same time. So that's basically, in a nutshell, the difference between them. It's that a GPU has parallel processing, can process a whole bunch of things at the same time, but really reduced instruction sets, simplistic things, and multi-threading. They can do all those calculations at once. And then CPUs have a lot fewer cores, but a lot more memory per core, and the kinds of computations they can do is more complex. Okay, so let's look at OpenGL in Max. So if you want to render something in OpenGL in Max, you need three things. First you need a renderer, something that's actually going to take the drawing commands and create the textures to be rendered, or render them actually. You'll need a window to display that rendered frame. And then you'll need some kind of object that's creating those drawing commands. So let's start with a renderer. GL render. GL stands for OpenGL. And we're also going to need, let's start with a simple drawing wrapper for OpenGL called jit.gl.sketch. Okay. And we'll also need a window. So jit.window. Not pwindow, window. All right. Let's make this window floating. We can make it floating by saying @floating1. Now it will always be on top of our max patcher. When we render something in OpenGL, we have to give it a rendering context. If we don't, it makes up one for us, and it's like this crazy U124863. It's some kind of random number that it makes. It's better to work with a rendering context that you've specified. That way you can always make sure that everything is on the same rendering context. You can think of these rendering contexts as your own like GL universe. Everything that has that context is in that universe and can be viewed by other things in that universe. So let's call this, let's call it OpenGL. So jit.gl.render OpenGL. Now we've put this in the OpenGL universe. Let's put the window also in the same OpenGL universe. So just put OpenGL in here. Now this window has a name that's called OpenGL instead of that crazy U12838557 whatever. And also we'll need to put this sketch in the same universe. OpenGL. Okay. In order to render, we're going to need to send a bang and probably the a message that says erase to the GL render object. Go ahead and click the bang. Oh, it doesn't do anything. I haven't sent anything to it yet, I guess. I thought it would make this background turn gray, but it doesn't. Okay. Let's see. Am I missing something? No. All right. Let's just go ahead and start sending different commands to the sketch. Open the help file for this JitGL sketch and go to Drawing tab up here. This is a sample of some of the drawing commands that you can send to this thing. Circle, frame circle, which would be like a circle with a hole cut out in the middle. Sphere, cylinder, torus, plane, cube. And then you can tell it to move to different places and draw a line to different places and stuff like that. There's a whole bunch of advanced commands for JitGL Sketch. I don't use JitGL Sketch a lot, but it's a good teaching tool for showing you guys this stuff. Let's start with something simple like a circle. Send the message circle 0.5 and send that to the JitGL Sketch. There we go. Now that it has a command, it does turn gray the way I said. So you send that to the JitGL Sketch by clicking on this. Then you'll actually, in order to see it, you'll have to bang your renderer to render that frame. And you see the circle. Does everybody see the circle on theirs? Is it not? Do you have everything on there? Is it just not working? You probably have something wrong in your universe on your JitGL Sketch or your JIT window. All right. So the erase message, what that does is it erases the previous rendered frame. If we never erased, we would just start stacking images on top of each other. And sometimes that can be a cool effect because you can make things like trail around and stuff. But for the most part, you're going to want to render and bang the renderer and then erase. Or actually, a lot of times you want to erase first and then bang the renderer. So you're erasing the previous frame, banging the new frame. We'll add a Q Metro to this in a second, so we won't have to keep clicking and clicking erase. All that will be automated. Let's look at some other shapes. Plane. Let's do like a plane 0.7. PLANE. That should draw a square, but not until I hit the bang on the renderer. What it's doing there is it's doing some kind of, the circles underneath it. If I erase this frame and redraw it, you should just see the square. Okay, GL Sketch keeps a record of everything you draw in it, and it will continue drawing those. The circle is still there. It's underneath the square right now. Let's add a clear message so that we can clear anything that the GL Sketch has previously drawn. Put this over here. So now if I hit clear and I bang the renderer, clear. Oh, I never erased my frame. See, I'm banging the renderer and I still see this stuff. I have to actually erase the frame, then bang it again. Why is that not working? Oh, no, it's not clear. That's why. The word is reset. That makes it go away. So those are a couple two-dimensional objects. You can also render three-dimensional objects. Sphere, 0.25, we'll say. These values, 0.5, 0.7, 0.25, they're what are called normalized values. So a plane with a value of 1 will take up the entire screen. A circle with the value of 1 will take up most of the screen. Maybe it cuts off a little bit of the edges. But the width of it is the width of the screen. So 0.25, a sphere with 0.25 should be a sphere that takes up a quarter of the screen. There it is. Looks like a circle. Why does it look like a circle? Well, there's no lighting. We haven't enabled lighting in this. Without lighting, we're seeing basically the shadow of the three-dimensional object, which we just perceive. Just a shadow of a sphere looks like a circle. So we have to give it lighting in order for us to tell that there's a circle there. Because basically, I mean, I say shadow, but really what it is that every single face of that sphere looks exactly the same color. So we can't tell one face of the sphere from another face of the sphere. If we give it lighting by saying @lighting enable lighting underscore enable 1, then resend the sphere command, then erase your render and bang it. Now you can see the sphere as a sphere because it has lighting. You can actually, we won't do this today, but you can actually reposition this light in the OpenGL universe, and it's really cool. You can have the light move around and really sell this thing as being a real object and not just a 2D graphic. Yeah? Yeah, so erase your previous render frame and then bang it again. Does that fix it? Okay, let's go ahead and to save on sanity, let's automate this erase and bang thing because it's driving me crazy already. All right, so we're going to use a Q Metro. Q Metro. Let's have this bang at 30 frames per second, 30 hertz. Send a toggle into it. Okay. And now we're going to use a trigger message. Which one do I want to do? TB erase B. Bang, erase, bang. We've used the trigger before, right? Trigger takes whatever you send into it, in this case a bang, and outputs what you put as its arguments. And you can use shortcuts like B for bang. The order, basically when you type it, you're going to type it in the reverse order that you want it to output. Because they want the arguments to line up with these outputs. And max, remember, the order of operations in max is from bottom to top and from right to left. So this B is this outlet, the erase is the second thing that comes out, and then this bang is the third thing that comes out. It's kind of stupid that you have to type it backwards. If I were redesigning Max from scratch, I would make it work from left to right instead of right to left, but that's the way they designed it. So, okay, so send this erase and this last bang into the GL render. We're gonna save this first bang for some movie stuff that we'll do in a little bit. This will be to actually bang the movie players when we move on to that. All right, go ahead and turn on your GL Metro. I'm sorry, your Q Metro. And now, if I hit plane, it just puts it there. If I hit circle, it puts it there. I can reset and everything goes away. It just works now.
My window showing shapes.
Then you probably have something wrong with the title of it. What's your window okay, what is your GL sketch? Look at its universe, look at your render universe and your window universe and make sure they're all exactly the same.
The space in the
That would do it. Okay. So that's some basic primitives. You can also do things like move. With this GL sketch, you can do things like move to like -0.7, comma. Oh, actually, it's a 3-dimensional message. -0.7 space 0.5 space 0. That's the X, the Y, the Z coordinate, comma, new message basically, and then plane 0.3. And that's going to move up into the upper left-hand corner and draw a square. Yeah, here's the numbers. And make sure you have this comma between these two messages.
What is this thing?
That's sending the command move to those 3 XYZ coordinates to this GL sketch and then draw a plane with 0.3 width.
So it's giving an order.
Yeah, and now if you put a sphere, it remembers that that's where it's located. So if I say sphere now, it'll put a sphere up in that corner.
Can you show us how to do it?
At lighting enable 1. No. Oh, if you change any parameter inside this, then it will probably clear out everything you do. You'll have to redraw things. Because whenever you change a parameter in the object, it reinstantiates that object. So it forgets whatever you were doing before.
So by adding a move to, you're actually moving everything else?
No. This GL sketch, it's an older way of drawing things, where it's giving it a list of commands on how to draw drawing commands. And the way drawing commands have worked since the very beginning of vector graphics is you got this little turtle, is what they called it back in the day, that starts in the middle of the screen. And if you want to draw something up here, you have to say move here, now draw a circle. And this works the same way. It's now if you say move here and draw a circle and then you say draw a square, it's still here. You have to tell it to move back to the center if you want it to move back to the center. Yeah. This GL sketch works the same way. That's why it's kind of weird, and there's some better ways of doing this that we're going to look at in a second, but this was a good way of just showing you some simple drawing commands. Let's see. Yeah. You notice that this square looks this sphere kind of looks weird. So do your move to plane and then do your sphere, and see how this sphere looks weird? That's because we're rendering a camera angle right now. So that's a perspective thing based on a camera angle. The default camera angle for the GL render. We can turn that off by either setting an orthogonal mode in GL render, or on the actual object that you want not to do that, you can use a TransformReset, which will change how the renderer renders it to ignore lensing angles and ignore like aspect ratios and stuff like that. I use this all the time, so I want to show you right now. It's called @TransformReset 2. No, 1. Sorry. Now go ahead and say your move to 0.7, 0.5, plane 3, and now say the sphere, and the sphere is a perfect sphere at that location because it's ignoring those lens angles and it's projecting this orthogonally. @transform_reset 1. That's making it. That's overriding the camera angle, the default camera and perspective views in the GL render object, and instead rendering this orthogonally. If you want to find out more about this stuff, it's in every single any GL object. If you go down to where it says O3D object, where is that? This is a huge reference. I didn't realize that this was such a large reference. There we go. Down here at the bottom, you'll see OB3D messages. The reason they put this in a drop-down list is because it's the same things will apply to any GL object. In there, you can look for where it says TransformReset. Well, I thought it was in here. No, maybe I'm wrong. I'll come back to this. Anyway, I'll go over those in a minute. I think I saw it in the JIT movie player, which we're going to move on to in a second. So that's one way of viewing things. There is another way to look at objects, or to render primitive objects, and that is there's GitGL Play-Doh and GitGL Grid Shape. GitGL Play-Doh. It's short for platonic solids. You know what a platonic solid is? It was developed by the ancient Greek geometry mathematician Plato, who discovered that you can make a number of different solids by tessellating equilateral two-dimensional objects. And like a tetrahedron is made out of 4 equilateral triangles. A cube is another platonic solid, and it's made from 6 equilateral parallelograms or squares. And there are other ones like an icosahedron, which I think is made of like 12 equilateral triangles, and there's one of them is made out of pentagrams. So this can do some kind of cool, semi-useful things. Let's put this in the same thing. We have to put it in the OpenGL universe. So GL Play-Doh at OpenGL. Sorry, no, just OpenGL. GitGL Play-Doh space OpenGL. No, that's a dot. Yeah. Then yeah. And then we can let's set a scale on this so that it doesn't take up the full screen. Let's do at scale 0.3, 0.3, 0.3. That's X, Y, and Z of 0.3. And let's do our transform reset on this as well. At transform reset 1. Okay, so by default it's a tetrahedron, but let's do lighting enable, or else we won't be able to tell what we're looking at. At lighting enable 1. I believe it's a tetrahedron that's facing us right now, so it looks like a square. There's an object that'll let you grab things on the screen and move them around, and it's called GLHandle. And attach that to the GL Play-Doh object. And now I can move it. And now you can see that it is a triangle. What? Did you attach your GLHandle to your GL Play-Doh object?
Do I need to reset it?
Just grab the object on the screen and move it. Is it not working?
Yeah, it should work. Now grab it over there. Try just, oh, you spelled handle wrong.
What transform reset?
No, you didn't. Just add a character and then take that character out. Now it should work. Try it. Oh, you never attach this stuff. Attach this to this so you don't have to keep doing that bang and erasing. Yeah, you're going to need that erase message in there as well. There you go. Now go ahead and grab the. Oh, yeah, that needs to be a toggle. I turn that toggle on. Now it should be rendering in real time. Yeah. Yes.
So I don't know if my transform reset.
Yeah, looks like it is.
Okay, it was when I did this. This has to be.
Yeah, that looks right.
I thought it was supposed to be blurred more. Is that supposed to be blurred?
Yeah.
Okay. It was just smaller. I couldn't see.
Yeah, mine is a little stretched out. This projector is stretching out my screen. It looks a lot more. It looks more in the correct aspect ratio on my screen than what the projector is showing you guys. Yeah, so that's how you can move things around. Let's see. Oh, GL grid shape. Here, let's add the ability to turn this stuff off. So go make a toggle and put a message underneath it that's enable $1. So this will be sending either an enable 1 or an enable 0. And send that message to both the handle and the Play-Doh, so that we can disable the handle and also disable the Play-Doh. And now when we send that, it'll turn it off. Okay? Let's just duplicate this. Oh, sorry. We haven't even looked at other shapes. Let's look at some other shapes of the Play-Doh first. Just right-click on this inlet here, and it brings up a whole bunch of different things that you can send to this object. And click on where it says shape, right here. And that will create a little attribute UI for shape. And if you resize this so that you can see the shape, now I can use this drop-down list and look at some other ones. Like here's a hexahedron, otherwise known as a cube. an octahedron. It looks like a U menu, but it's actually a attribute UI or an attrui object. But you can right click on the inlet to GL Play-Doh and then click on shape down here. And that will create one of those for you. And so you can look at some of these other ones. A dodecahedron, which uses pentagons. An icosahedron, which uses, I believe, 16 triangles or something. Yeah, this is like, icosahedron is like the Dungeons and Dragons die. If you ever played Dungeons and Dragons, you got that like 32-sided die or something. Where is from this sketch thing? Just send the reset to your sketch, and that should delete it. Do you have more than one GL Play-Doh? Let me take a look.
Okay.
All right. You've probably okay, actually, let's go ahead and look at GL grid shape, which is a really similar object. Go ahead and just duplicate all of this code. Grab everything you did here and duplicate it. And now change this from GL Play-Doh to GL grid shape. And go ahead and disable the GL Play-Doh object. Grid shape's default object is a sphere. And you can move this sphere around and look at it in different ways. It looks a little jagged. There's a method to smooth out the jagged edges called @smooth_shading 1. Now it's a smooth sphere. Well, more smooth. You can still see kind of the edges. At smooth_shading 1. Go ahead and look at some of the other shapes that you have available. A torus, which is like a donut. A cylinder. I believe they have an open cylinder, which is a cylinder, which is an extruded circle, basically. Different shapes. Play-Doh is only platonic solids. GL grid shape are these primitive shapes that they have. Cube, you can do this in both of them. Open cube, which is a box that's open. Plane, which is a square or a rectangle, depends on how you scale it. Circle. And cone and capsule. They just added capsule in Max 6 because it's useful. Capsule is really useful for collider shapes. If you're doing physics, and you can do physics as of Max 6, usually if you have like a human-shaped thing, you have this invisible capsule around them that is the collider, so when they run into something, it'll detect that or not let them go through walls or whatever. Yeah. All right. So you probably noticed that the background is gray in this. And why is that? Well, the reason why is that that is the default erase color for the GL render. What is an erase color? Well, when you think about if you're going to erase a frame, what are you doing to it? You're really just painting over it with a color. And we normally would think of that color as black, right? But it doesn't have to be black. And I think that's why they made it this like 75% gray, is to remind you that you haven't set an erase color, and that an erase color doesn't necessarily have to be black. It could be green, it could be yellow, it could be some shade of blue. But we can set an erase color on this GL render. Let's go ahead and set it to black. So you can say at erase color, and then it's 4 different floats. And I think when we were doing matrix-based video, it went alpha, red, green, blue. In OpenGL, just because they want to make everything difficult for you, it goes red, green, blue, alpha. Yeah. So it's so if we want it to be black, it would be 0 period 0 period 0 period 1 period, full opaque black. You don't necessarily have to have full opaque black. I could make my erase color like a 0.5, and then if I move things around, you'll still see a little bit of what was there before. I wonder if that'll work. Let me try that really quick. 0.5, and now move this around. Now it still seems to be the same to me.
What's the highest number?
What? 1. There's a normalized values between 0 and 1. Oh yeah, it kind of works. There we go. So change the erase color to something really small, like 0.1 or 0.01. And now move this thing around. And you can see how it's not quite erasing it, the previous frame. Yeah. And it does this kind of weird tail effect. It's because we're drawing over the previous frame with something that's mostly transparent. Oh, how do I move the object? If you hold down Command, that will actually. That's why I have mouse pose on, so you can see what I'm holding down. Yeah. Yeah. So say we wanted it to be erased with green. Let's go ahead and put this back to a full opaque pixel, but change the second number from 0 to 1. Now it's erasing with green. So you can do this whatever you want. And say you wanted Max to render some graphics, and then you're sending it out, and you're doing chroma keying on something else with green to replace that with like a live video or something that's coming in. This is how you could do it. You could send full green as set full green as your erase color, and then when you send it into your, say you're using a hardware chroma keyer, and this is the input that you're sending to your hardware chroma keyer, and this is a perfect green, and it'll just end up being transparent on that old school chroma keyer.
Can you change the color of the object?
Yeah, yes, I believe you can. Let's try that. Let's set this back to black. I don't want to give myself a headache. You can send a color message to the grid shape at color. Say, let's set this to be blue. 0 period, 0 period, 1 period, 1 period. And now it's a blue sphere until I change the shape of it. Yeah, or you could change it in the inspector. Any of these things that I'm doing with attribute messages, you can do in the inspector. The benefit of doing it as an attribute in the actual object is that is the value that will be loaded when you load the patch. So if you wanted a blue sphere in your patch and you saved it, if you set it this way and you saved it, when you opened it, it would be blue. If you did it in the inspector but you didn't set it in the name, then it's not going to keep those values. Unless, there is a way of making it keep its values. It's something we haven't used very much, or at all actually in this class. It's programming preference. Some people like to do it this way. I like to put all my @ symbols so that I can see what the hell the thing is supposed to be right in my patching window. But you can change the attributes here and then lock them with this snowflake icon, which is the freeze. And then that would hold that attribute even when you instantiate or reloaded the patch. But I don't do that. That's not my style. Okay. So another, yeah. So you'll notice when you're working in OpenGL with all these attribute symbols that your objects will start getting really wide. What I usually do is just resize them, and I try to get it so that all the @ symbols line up like that. Then it makes it really easy to read. The only thing that sucks, and I hate this about Macs, is that as soon as I add a new one, it's going to go wide again. I wish there was a way to have it keep its aspect ratio and just, go to the next line. Maybe they'll do that for Max 8 if enough people complain about it. Okay, so we got grid shape, we got Plato. Okay, so that's cool for primitives, but what about video? Well, in OpenGL, video is just treated as what's called a texture. A texture is simply a graphic that it's a graphic that can either be a still graphic or a moving graphic, which is what video is. It's a graphic that is applied to a primitive or a grid shape or an object of some sort in your OpenGL universe. So we could set this as a plane and then send it video and then send it video in the form of a graphic, and that would work. The other way, but there's an object that's already set up for you for video, and it's called GL video plane. This, all you do is you can right-click on the object and then click on where it says shape down here, and then it will add that attrui for the word shape. Or you can just attach an attrui object to the GL grid shape and then change this to shape. That works the same way. Okay, so GL video plane. We'll also need a movie player actually to create the video. Just JIT.movie. Let's go ahead and instantiate this with 0 volume so we don't have to worry about sound. Vol 0 period. We're also going to want to do @unique1 so that we're only sending out unique frames. @unique1. And the old way, we used to have to take the matrix-based video coming out of a JIT-GL movie player or JIT QT movie player and send it to a texture object that would convert it into a texture. But as of Max 6, they added the ability of the JIT movie player, and I spelled movie wrong. They added the ability for the movie player to directly output a texture. So you can say @output texture 1, and that actually saves you some processor cycles and makes things a little bit faster. So those are your 3 arguments: @volume 0, @unique1, @output texture 1. We also want to give it a texture name so that we can tell these other objects which texture they want to load. So let's give it a name, which is @texture underscore name, and then give it a name, which I'm just going to call mine myTex. Okay? We're going to need a read message. Whoops, not one of those. And we're gonna need to receive some movie bangs, some bangs to this movie object to actually make it output frames. So let's do a receive movie bang, movie bangs. We never actually made our send for this, so duplicate this and change the receive to a send and move it over here to where we have this bang coming out of our trigger. So now that movie player is getting all of those bangs from the Q Metro. You guys all with me? Okay. Do you have a receive movie bangs? Make a send movie bangs just by duplicating this and changing the R to an S, and attach it to this bang right here on this TB erase B. Okay? And on this video plane, we need to make sure to put this video plane in the OpenGL universe. And this doesn't have to be the word OpenGL. It could be my universe. It could be whatever you want to put. I'm just using OpenGL for this class as a context name. We're also going to need to tell it what texture we want to apply. At texture my text. All right, now let's read a movie into the movie player. And there it is. Go ahead and you can turn off your grid shape. So by default, your video plane has a scale of 1. It's square. It's a little bit rectangular in this, and that's the projector's fault, and not mine.
Does the video have to do this? Is this another thing that the folder is
Yeah, I guess. Just if you say read, it should open a dialog box, and if you read a movie in the player, it should work. Whose isn't working when they read a movie player, or read a movie into it?
I just need a second on that.
Can it be .mov or does it have to be?
Yes, it can be a .mov or an MP4. Either one.
And it doesn't have to be directly. No. If you read it directly into it with a read message, you should know where it is. And you might have just sent something really weird into it. Read something normal. That's what's the tag on it? I don't see. It doesn't know what that file is. It doesn't have a .mov. Yeah, read one of those. Okay, then you probably have something else wrong. You're moving my texture. Okay, so your texture is wrong. The texture underscore my texture should just be at texture name.
Yeah, just 1 second. Here, let me zoom in. This projector, I think there might be something weird about the projector settings.
Yeah, I feel like I usually can see it.
Yeah.
So you usually the video in as a background to this object.
There we go.
Then the sort of echoing, erase echo stuff that we were doing before is no longer visible.
The what?
But like the sort of erase echo that we were doing before.
Well, we turned that off when we reset our erase color to being 1.
I know, but I left
then the texture itself is not going will override that. If you were to move this thing around, then yeah, you would still see those trails. The plane. If you were to move the plane around, you would see those tails. You go into Applications, find your Mac 7 directory, right-click on it, say Show Package Contents. Go to Contents, Mac OS, no, sorry, Resources, C74, Media. This is why we did a shortcut. And Jitter, and drag this into your favorites over here. Anybody's need help?
One second. Okay, cool. Yeah, question?
in this drop down, I mean, in this drop down menu, do these affect the shape? What are all these other?
Yeah, they all do different things. I could spend the week going over all of them. A lot of them we won't be using.
Okay, but they all affect, like, so
They're all parameters of that object.
of this object.
Yes.
And in order to use the parameters of this object, you can go through all the parameters.
You can if you want. If I want them to look a certain way and I want it to always look that way, I instantiate them with the arguments that those represent. Yeah.
Okay, so this video plane by default is a square, and it looks more square now that I fixed the projector, which isn't taking into account the aspect ratio of the video, right? And that's because that's where that transform reset thing comes in. So on this video plane, let's set the transform reset at transform reset. 2. There we go. And now it will make it in the same aspect ratio as the video. What was that?
The aspect changes.
Yeah, it depends on the size of the window, really. Here, let's make the ability to make our window go full screen. Over here on the GL window, let's do the little escape key trick. Just do new object key, and then send a cell 27, because that's the ASCII code for the escape key, and attach that to the first outlet of the key object, and then take a message that's full screen $1. Pass that into the window, and now I can. Oh, whoops! Sorry, missed a toggle. Send this output of this cell into a toggle, and then send the toggle into the full screen one, like that. Okay, so now when I hit escape, it'll be full screen. You'll probably notice there's still a menu bar up at the top. That's kind of annoying if you're actually wanting to use this for a performance thing. To get rid of that, on this GL window, you can say at FSMenuBar 0 to disable the file system menu bar. Now there's none of that on there. Remember, $1 is a wild card. This toggle sends a 0 or a 1. That toggle is being activated by the select 27, which is the 27th ASCII character, which is the escape key.
So full screen is the message that.
Yeah, if you sent it a full screen one message, it would make it full screen, but then there would be, if we didn't hook it up to the key, there would be no way to get out of it. Yeah, right? You can get out of it by like doing an option tab or something to switch to a different application. That will get you back your monitor. Yeah. Okay. So we were looking at mixers, a video plane. So we got video playing on a plane. This doesn't necessarily, you don't necessarily have to put video on a flat plane. You can put it on other objects too. Let's go ahead and edit our GL Play-Doh down here, and let's give it the texture of this. So at texture, my text, and re-enable it. And actually, in this case, we might want to turn lighting off on it. Zoom out. What do you mean? Oh yeah, that is weird. So annoying. Hold on.